Tristan, what problem are you trying to solve here?
So with the energy transition, there's a lot more of these inverter-based resources that are needed on the grid, whether it is like photovoltaic panels or energy storage, and they are injecting a lot of electrical disturbances in the system. And obviously that's threatening the reliability of the whole grid, and that's causing some problems like the fact that the lifetime of very expensive industrial equipment is being reduced, or the fact that there's injection of these disturbances that are increasing the stress on the grid and potentially increasing the likelihood of blackouts on the grid. And there's as well the fact that it's decreasing the overall efficiency and performance of the system. So by enabling the implementation of power quality monitoring, we can have a better use of the existing system, and that's thanks to predictive maintenance. That's thanks to diagnostics capabilities that are provided. And in the end, that's going to enable the fact of having a higher ratio of renewable energy in the grid, and that's what we all want in the end.
Okay. Now, to come up with a solution to this, what's the challenge that you need to overcome?
Right. So the power quality standards that are out there are fairly recent, and they are pretty complex as well. So it's very resource intensive to come up with them. And that's something that we have noticed, and we try to facilitate with coming up with pre-certified solutions. So there is as well the fact that the Class A power quality monitoring standard is an industry standard that people are much more familiar with.
Okay, yeah.
And that's something that we, as Analog Devices, wanted to look into the next one, which is the Class S power quality monitoring solution, according to the IEC 61000-4-30. The Class A is here for very stringent, very accurate, and here for billing disputes, and here to take legal action. But the Class S power quality monitoring is going to be 80% there in terms of technical requirements, and much more attainable. So for the designers, it's the barrier to entry is much lower, and so it enables for us to have a broader set of customers that can insert the power quality function into the system.
Okay. And if I may, so what solution has Analog Devices come up with for this?
Right. So we've had some high performance power quality Class A solutions thanks to our ADCs that we've had in the past. But in order to make it easier to implement, in order to make it much more affordable as well in a way for our customers, we wanted to have this Class S solution, and that's what we created and released this year with this AD 9430. And it's basically composed of a high-performance energy metering chip that is coming along with a power quality software library that is running along on the application MCU. And that is here mostly in order to do some polyphase AC metering for utilities, as well as some transmission and distribution, and finally as well some industrial automation. This is where we see these things.
So I can get, let's say, metering data, power quality in far more places,
right?
Let's say in a factory, right? And now with energy efficiency, the price of energy, all sorts of other use cases can be built on top of this technology.
Totally, by making it easy to use and more affordable, like much more people can use it, and actually like the power quality requirements and parameters that are provided can be used like in a far broader set of use cases at that moment.
Hey, good stuff. Thanks a lot.
Thanks a lot, Kevin.